Local AI is way more usable, way more powerful, way more efficient, and way more accessible than you might think. This documentation, it's using a free model running on this laptop. Every line was fact-checked to make sure it wasn't hallucinating. No find and replace, no redaction scripts, just raw configs straight into AI. Nothing left this laptop. If you're a network engineer, you already know why that matters. Everything you can't paste into ChatGPT, you can just ask. Now, there are two big caveats with local models. You need hardware that can run these models, and even then, they're slower than the frontier stuff. And they'll lose on the hardest reasoning. But do you need frontier models for the tasks that you're working on? We're gonna dive into the pros, cons, and real use cases today. So buckle up, because this is gonna be a fun one. I benchmarked 6 models against real network configs so you can see what your hardware actually gets you, including what a budget machine can run. So first we'll install Ollama, takes about a minute. We're gonna run it against our home lab. Then we're gonna talk local AI trade-offs, including when local AI is enough, when you need to upgrade to a frontier model. And as always, I'll have a free guide on my GitHub walking through how you can do all this yourself in your lab. Local AI is getting really popular lately. You guys have been asking for local model content, and for good reason. With local AI, there's no need for redacting configurations, nothing goes out to the internet, and there's no token cost. And if you've hesitated to paste a config into a chatbot, you're not alone, you're not paranoid. A config is a map of your network. It's very sensitive information. And as of this year, insurance companies are putting language in their policies that say, AI-generated losses, sorry, we're not covering them. So the privacy angle is real, but this is not an anti-cloud video. I use cloud AI every single day, and it's my primary use case. But I do think there are use cases for local models, and that's what we're going to talk about today. So let's get Ollama installed and get into the lab. We'll just go to ollama.com/download, download this, save it, install the app on your Mac like you would normally do, and then just simply go to your terminal app that you prefer. And we're just going to do a Ollama -- version. This is the version we're running. And just a quick note, if you have issues with Ollama not working in CLI after you install, don't be like me. Just make sure that you actually launch the app for the first time, and you'll see it running up here in your taskbar. And then to get your model that you actually want to run, just open up your web browser again, go back to Ollama, and then you'll just click on models. And then we're going to be using the Qwen 3.6 model, which I think it's pronounced Qwen. We're going to grab the 3.6 35 billion parameter model. So we're just going to copy this, go back to Ghosty, and we're going to say Ollama pool. And then we'll just paste that guy in. And we've already downloaded this model. So you can see here, it just says, hey, it's already successful. If you don't, it's a 23 gigabyte model, so it'll take a little bit. And then we'll just do Ollama list. This will list our currently installed models. You can see here the 70 billion parameter model is 42 gigs. Qwen 3.6 is 35 gigs. And if you ever are in the middle of a pool and you lose your internet connection, just restart it once you get Ollama back up and running, and it'll pick back up where you left off. Now, before we go running anything serious, there's 5 settings that we want to change. And when you first get Ollama installed, it's tuned for just a standard chat, because that's typically how people start. We're going to be feeding it Cisco configurations, which has way more context. We're just going to paste in these settings here, and I believe you can change these in the GUI as well, and I'll explain these later. So that's set, and these are basically just environment variables that we're setting for Ollama. Now, once you put these settings in, you do have to restart the Ollama app. So we'll do that now. So that handles our setup. Now let's talk about what our Mac can actually run. So here's our ladder. 6 models, all measured on this machine with the same prompt. Top of the ladder is 75 tokens a second. That's faster than you read. Bottom is under 7. The 35 billion parameter model runs 4 times faster than the 27B. It's a bigger model, same family, same machine, 4 times the speed. Now, how is that possible, you ask? Let me show you. So we're going to go back to our terminal, and we're going to run Ollama show Qwen 3.6 35B. If you look here, this is the architecture, Qwen 3.5 MOE. If we do this again and check the 27 billion parameter model, this just says architecture Qwen 35. So one's an MOE model and one's just a standard non-MOE model. So what's the difference? What does that mean? MOE stands for mixture of experts. A non-MOE model is considered a dense model. A dense model runs every single one of its parameters for every single word that it writes. A 27 billion model does 27.8 billion parameters worth of work per token for every token. The mixture of experts model splits those parameters into specialists, aka experts, and wakes only a few per token. So the 35 billion parameter model is bigger on your disk but only a fraction of it is actually active and doing things at a time. So it runs faster and saves resources. Now, there are a couple caveats to this. I'm not going to get into the details of that right now, but in general, an MOE model will allow you to run a bigger model faster. So here's a clip of me testing the 70 billion parameter model. I'm not going to bore you with doing it live because it does take a while to load. So you can see here, it's how this is real time, how fast it's printing out the tokens. So it's, not horribly slow. And then if we look up our activity monitor, you can see the CPU usage here looks pretty normal. But if we go to memory, it's using 45 gigs of RAM. That's crazy. Okay, so enough benchmarks. Let's actually make it do some work. Hey, real quick, everything I'm setting up here, the settings, the fixes, the config files, the lab topology, it's all free and a link in the description below. If I've ever saved you time or you get value from this type of thing, you love AI, network automation, AI for NetOps, the best way that you could say thank you is just by hitting that subscribe button. It helps me out a ton and it helps me continue to bring you quality content. Now let's get to the lab. Okay, so here's the config file that we're going to be testing with. It's just core router 01.cfg. WC-C just tells you the size of the file, and this is about 44 kilobytes. This is a show run all config file, so this is a sizable thing here. And if we open up VS Code, there's 1,500 lines. So it's about 14,000 tokens that we're going to be sending to our local model. So this should be a pretty solid test for us. So we'll open our terminal back up, and then we're just going to paste our prompt in here and hit enter. So this just says Ollama run when 3.6, 35 billion in verbose mode, which just gives us more output. And then it just says you're documenting a network device for an engineer handoff from the following running config, produce an interface table, routing summary, a list of configuration risks, and then the config follows our file, our running config file. We'll just let this print off here. Now this gray text on screen is its thinking process. When the text turns white, that's its actual output. All right, so it's printing our output here. Here's our handoff documentation. We've got our interface table. We've got our routing summary. We have our configuration risks. Says, we're not running IPv6, CEF. Is anybody? A TCP issue, a crypto IKv2 issue. But again, this is all running locally on my laptop. There was no cloud involved here, and it gave us this whole runbook. That's just so awesome to me. Now, don't just take my word for it. Let's actually check the output against what our running config shows. We're going to open up our config file that we used. We will look at the interface table. Okay, so we have loopback 0. Here's the IP address. It matches. Yep, that looks good. Let's check interface 00. 192.168.1.50/24. Yep, that's good. And then we'll just check 01 just for funds. 10.0.12.2. Perfect. Now let's be real. I'm not going to sit here and fact check the output against 1,500 lines of config. And that would also defeat our purpose of using AI to help us do our jobs faster. So AI is very good at this. And if you're ever not sure and you don't want to sit here and verify your config file against your runbook that it just created, maybe you can send this output to a 70 billion parameter model. Sure, it'll run a little bit slower, but go grab a cup of coffee while that runs and say, hey, double check this output against my config file. Or you could even just take the runbook that it just gave you, take your config file, give it to ChatGPT or Claude through your company's enterprise subscription that's protected, and say, hey, this is my first time messing with local AI. Double check these and make sure that it didn't miss anything. Make sure that its output's actually, correct. Then you start to get a little bit more comfortable with it and you can trust its outputs more. But in a real environment, I think you're going to be able to eyeball the runbook and kind of see if anything major jumps out at you. Now imagine a situation with me. You're a network engineer and you're getting audited. Somebody says, hey, we need new updated network documentation by the end of the day. You're looking at your Visio docs. They haven't been updated since 2023. You have a SharePoint page that hasn't been updated since 2 admins ago. And you're like, crap, where do I start? I don't have an enterprise AI subscription. You can install Ollama in a minute, install a local model on your machine, give it some config files. Boom, you have an interface mapping. Give that to a draw.io and an XML file. All of a sudden, you have a network diagram for free. You still verify it. That step never goes away, but you're starting from a draft versus a blank page. Now, if you remember, you might not have caught it when you ran it the first time, so I'll show it here in terminal again. So by default, any model that you start in Ollama runs with a 4096 token context window, which if you know anything about models, that is very small. So in order to be able to run bigger prompts, you can run this command, and this just sets your context window to 65,000. You can obviously make this bigger, you can make this smaller, change it based on your needs. But this set env will set it every time you launch Ollama so that you never have to worry about it again. You can also change the context window in the GUI. So here's an example of what happens if you run it in just the default 4096 context window. It's hard to see here, but it didn't actually even finish its output. It finished in the middle of its thinking process here. So I went ahead and set the context length to 65,536. And here in the output of the first prompt, it's got a prompt eval count of 2,050 tokens. So that's all the tokens it used. Now, if we set our context to 65,000 and then rerun this, watch what happens. You do have to restart Ollama. Okay, so the second prompt finished here, and you can see it used way more tokens. Your eval count is 14,000 versus the last prompt, which was 2,000. So it's actually digesting what you gave it. And the eval 14,000 about matches what we said it would based on the number of lines and the size of the file that we gave it. So here's another example. Your context window has to be big enough to hold your prompt, the model's thinking, and its answer, aka its output. So in this example, I paste in 2 configuration files and a question, and it almost gets there, but then it hits its limit, and I'll show you. You can see we gave it 2 files instead of just 1. Now watch, it's gonna print us off a gorgeous table and then just stop mid-print. So you can see here, the table just gets cut off, and then the important part, it hit our token limit. In this case, I had set it to 32,000. I think if you add the 28 plus this 4377, you're going to get closer to your 32,000 if my math is mathing properly here. Now, another example is if you mistype a file name, instead of the command just failing like you'd be used to, it'll actually run the prompt. It will just tell you, hey, I couldn't find the file. So if we just say summarize this config, and then we're going to typo this, delete that. And yeah, so at the top, like it's still running your prompt here. You're going to have to scroll up to the top to see the error that, hey, there's no such file or directory. So just something to keep an eye out for. Okay, now the last example. And this one's kind of an edge case. But in this script, it takes the same router config, sends it to Ollama running locally, and then asks for the interface table back as JSON. Name, IP, subnet mask, description, the same thing that we just did in the last chapter where it printed off everything for us in plain text, but instead this sends it back to us in JSON in a structured data format. However, if you let the model run in thinking mode, it puts the thinking in your JSON, which then fails because JSON obviously wants to start with a curly brace, not plain English. So you can go into the environment variable settings and you can change the thinking to off so that it'll actually give you what you want. And you can see here the schema failed, think is set to default, and there's just some validation errors that the input value is incorrect. So that's local AI working and local AI fix. Now the big question I'm sure you're asking is, how does it stack up against the frontier models that I pay $20 a month for? Okay, so we're going to run the exact same prompt that we ran in Ollama, and we're just going to run it in Claude just to do a quick comparison. We're going to run this in Sonnet 5 effort level high. We'll hit enter, and this is a little bit sped up, but this took about 25 seconds. I timed it as opposed to about 2.5 minutes. So that's a time comparison. Now, what about the accuracy comparison? So there are some differences here. And primarily, it's just the level of detail that Sonnet went into versus Qwen. As far as our interface mapping, everything matches here. So we have our loopback 0 interface, 10.0.0.1, that matches over here as well. ETH.0.1, or I'm sorry, ETH.0.0, 192.168, 1.250, that matches. 12.2/30, that's good. The routing summary matches exactly as well. And then where it starts to differ a little bit is the configuration risks. And that's primarily just because the model is using its own reasoning to come up with these. These aren't deterministic things. The top one for Claude is HTTP servers enabled. And then the top one for Qwen is no IPv6, CEF. And then CDP is enabled. I don't know if Ollama found that one, or if Ollama even thinks that's an issue. Qwen is not concerned about CDP very much here. So there's definitely room for improvement on the Qwen model here. But if you're just looking for documentation in terms of interface mappings and what my running config looks like, I think it's really good. We could go into more detail and do like more in-depth comparisons between these, but I think your best bet is actually doing testing for yourself. Spin up some local models and test it, compare it to Claude, see what the differences look like. But in general, from my experience, these local models are really powerful. And more importantly, it's free and it's private. So here's the trade-off. For documentation and extraction work, local is genuinely enough. The cloud buys you speed and deep reasoning. So when you have super complex problems, you're trying to correlate multiple devices and get best practices for specific configurations. Ultimately, your frontier models are going to be better at the moment. Unless you have a absolutely bonkers local machine and you can run insanely large models, frontier models are still going to be better for those deeper reasoning tasks. Now, I keep saying private, but on this channel, we don't just make assumptions. So let me show you how and why it is actually private. We're going to do a live socket check on our Mac so that you can see the actual network traffic that's running as we run these models, just so that you can feel a little bit better about it being fully local. So currently you can see here we have 2 Ollama processes running, and this is filtering on Ollama. And you can see the IP is just my local loopback IP address. So we're just going to say, how are you feeling today? I don't have feelings. All right. We'll do a live socket test so you can see what the sockets look like while it's actually running. So how are you feeling today? Over here. You can see we have more actual connections being spun up while it's running, but everything is still local. Okay, so Ollama can run cloud models as well. So when you're making your model selections, just be careful. All the cloud models have a tag of -cloud, and also you have to have an Ollama account and be signed in. Here's just an example of what your network traffic looks like when you're running a cloud model versus the local model. So we're just gonna use this free model. We're gonna say hello. And you can see here, we actually have network traffic being produced by Ollama now, not just local. We have our actual external IP here from Ollama. Now, if you want to be extra sure that Ollama is not reaching out to the internet, just run this command, and this will disable web search and cloud models, which leaves us asking the question that your boss might ask, what does this cost? Let me be straight with you. This MacBook cost me about $3,300. You do not need that. The cheapest genuinely viable seat is the Mac Mini option, around $1,400. Sure, you can get dual 3090s, dual 5090s, and absolutely plow through your dense models, but you're going to be sipping on 600 to 900 watts of power. Meanwhile, my MacBook is running about 75 watts of power. And the reason cheaper hardware is getting more viable is because of the MOE models that we talked about. You don't necessarily need to get dual GPUs and run those dense models unless you're doing insanely intensive tasks. For what I'm doing right now as a network engineer, I don't need that. If I want to do local testing, this MacBook, a Mac Mini, is perfectly fine. In this last segment that I'm going to show you, we're going to test a 9 billion parameter model, and the results will surprise you. You can run a 9 billion parameter model on a 16 gig RAM laptop. We're going to use LM Studio. LM Studio just has a nicer GUI if you prefer GUI. Ollama is better for CLI work. You can see we're using a Qwen 3.5 9 billion parameter model in thinking mode. And then right here is just an MCP server that I added. You can add MCP servers to LM Studio just like you can Claude Desktop. This MCP server basically just has capabilities to ping live hosts and then also list interfaces just from a cached input to make the demo easier. So we're just going to say check whether core router 01 is reachable and tell me about its interfaces. And since it's using our MCP server, it's going to ask us first. So we're going to say, yep, proceed. It's not reachable. I tried to ping its DNS name. So we're going to say, yes, ping its IP. There we go. So it can ping it. These other interfaces it couldn't ping, that's by design. It can ping this, and it's pinging this just over my Tailscale subnet. So this is pretty cool if you want a nice chat interface like you're used to with ChatGPT or any of the cloud models. Now, as you saw in the LM Studio demo, there is the guardrail where you can manually click, allow the MCP tool to run, or you can set it to always allow. That's a built-in guardrail. You guys are aware of this. Just keep that in mind. Now let's wrap things up. First, we downloaded Ollama. We imported our environment variables so that we set it up properly. So we increased our context window, among some other things. I showed you 4 edge cases that you could run into and how to get around those. And then we talked about trade-offs. Local AI is free, private, and powerful, but ultimately, depending on the task, I think it's a viable option to switch between cloud and local models to save yourself money, keep things private, and at the end of the day, it's just fun to test. It's fun to see these models run locally on your machine. As always, all the artifacts, the walkthrough, the lab, Everything that we talked about is free in GitHub as a resource. The link will be in the description. You can find the companion blog post on my website. I'll link that below as well. On GitHub, there are dual platform settings in case you're not on Mac, how you can also do this on Windows. I also have the prompt pack you can get on my GitHub that you can throw into your local model and test them. And that would be a good example of something you can test against cloud versus local. And if that last segment got your attention about privacy and agent bounding, that's exactly what I built in my last video. I built a full network agent using a cloud model, but fully bounded, meaning it could not push any changes to my devices without my approval, even in bypass permissions mode. I'll link that video down below. If you made it to the end of this video, thank you so much for watching, and I'll see you in the next one. Hey, real quick, I'm gonna steal an idea from another YouTuber that I look up to, and I'm gonna pray for you guys if that's okay. So just hang out, close your eyes, and I'm just gonna pray over you real quick. Dear Lord, I pray that you would just be with these IT professionals, that you would just bless their career, their families, their livelihoods. I pray that you would just ease their worries about the job market that we live in right now and the AI hype. I pray that you would help us engineers and these viewers just have faith and confidence in you and your plan for us, and that we would be able to tamp down the anxiety that AI ultimately brings us. I pray that we would be able to use these tools and have fun and not be paranoid about what the future might look like. Lord, I pray that you would just be with these viewers, bless them, and that they might find hope in you. In Jesus' name I pray. Amen.